things for you. This should do it. If you need more than this, well, then you need more than this. 6 pages front and back. The first 7 sides are just kind of grouped all together kind of practice, so that if you want to focus on one idea specifically, you can do a lot of that type of practice over and over. Okay, the last 5 sides, I took last year's tests. I cut out some of the stuff we didn't do, and I gave it to you. You know what I did last year. Okay, and it's going to be, it's obviously not the whole test, but it's part of it. And I figured that style, like dealing with the multiple choices and all that kind of setup, I think would be very useful for you. So, again, I'm not going to check this. You can do as much or as little as you think you need to be ready for Friday. But if you don't do much and your grade reflects that, then you look in the mirror for who to blame on that one. So I tried to kind of partition it off. You'll see in the middle there at page 1, section 1, using the graphs, and then it continues there in the back. Section 2, doing stuff from a table. And some of them have limits. Some of them are just evaluating functions. Section 3, direct substitution. So, section 4, factoring. Section 5, rationalizing. Section 6, one-sided limits. Section 7, limits of trig. And if you need more trig, that may be the only spot where you can get a little more practice from me if you really need it. And then section 8, which was the last thing that we did yesterday, with that limit-based continuity. Now, you guys in front of me, I know you weren't here for that. Did it make sense? Right? Function defined. Limit exists. They're the same. All 3 of those are true. It's continuous. If any part of that falls apart, done. Discontinuous. You can just say that. Okay, so that'll be that last page right there. And it has that graph there. It has 3 different spots that you'll stop at. And you'll say, okay, let me check all 3 of those things. Let me make sure there's a point. Let me make sure the limit's there. And let me make sure that they're the same. And that's really all it takes to be continuous at that point. Okay? I'm going to do these solutions for sure. And I will get them out to you as soon as I have them done. And then, of course, like test number 1 practice kind of starts on the page right after that. And you see the same kind of style questions with the multiple choice. Some tables and some graphs and some continuity and some good stuff. So that's all there for you. Okay, the time is yours. Hi. Is that for me? What is this? Good and not good. Not here. Thank you. Yeah. Cool. Question. Okay, so let's look at that one. I think that'll actually, let's look at this one. Like something like that, right there. So, and I'll start it right up so that you guys can see it. And so go ahead, the time is yours. You can work. I will answer any questions that you have that you want to work through. Folks at home, you are good. If you don't want to stick around, you don't have to. I will see you tomorrow. You guys are good to go. So let me zoom in a little bit. Put in music, relax. I'll put on some music here in a second so we have something to listen to. And like I said, and then I'll get to Jazz's question. Like I said yesterday over the Google Meet, tomorrow, you guys in front of me, hop on for attendance. Make sure I'm there and I'm recording. Hear my little spiel until I say goodbye. And then if you want it, log off, log off. But I want to try to start giving you that break this week, because once we get to Monday and we start chapter 2, we're back on full schedule. So this is a great week to turn it off, right? Focus on other things. Obviously, you have 5, 6 other classes probably that you need to focus on as well. So if you need some time during our class time to work on that stuff, go for it. Hey, you know what? Even when you're here, this is your time. I highly recommend that you do every single one of these questions if you want to feel ready. But that's on you, right? You get to choose what you need, okay? So do what you need to do. Do what's best for you. Okay, so Jazz's question is actually really just the difference, and that's why I started with these 2, between what it's like to do g of -8 versus the limit of g of x as x approaches -8. And I think the key word that's going to help you, Jazz, is approaches -8. That it doesn't matter that, hey, the point is right there at -3, for sure. Right? When I'm just evaluating the function, where's the point? That's the question I'm asking. And if it's some like distant point kind of away from where the function I would expect it to be, then they'll make it nice and big in circles like this. But if I was going to like, I don't know, let's pick a nice one, like -3. There's a point right there. Okay, cool. So it's at 2, right? So they don't have to circle it in for it to exist and be a point right there. They'll only do that if it's something kind of weird that took it somewhere else. And so that's kind of what's happening with B, is that when I think about what happens as x gets closer to -8, as I travel along the function from the left and from the right, that blinking is shocking too. What is the y value that we're approaching? I know it's not there, but we're getting closer and closer to -6. And the path that I'm taking there by like starting at -11 or starting at -5 and kind of moving in that direction, that is way super far away. In reality, well, I don't know how close I can really get. But when we're thinking about, when I'm thinking about calculus, like I'm getting this close. I'm just getting closer and closer and closer. That's as close as I can get that way. This is as close as I can get this way. Like this is how I kind of, this is how I want to feel. Like what y value am I approaching? And that's how close I'm getting to that point, but not actually ever getting there. So that's the difference between something like g of -8 versus the limit as x approaches. Yeah. Tunes for those that want. The only thing I put up on Canvas are the answers to yesterday's stuff, page 76 and 76. If you guys want to check that out, I'll pull that up right now. There's something that you're not sure about, let's do it. Let's just talk it through. Let's go with that. Let me pull up the solutions. They're sitting on Canvas, right? I got pulled up the first 3, so I'll start with 4, 5, and 6. Kind of have to search for the answer. I tried to box it in or circle it. And while you work, I will do. That is the extent of my French, by the way. Yeah, sure.
on the second page
Uh-huh.
for F,
Uh-huh.
when it's split like that and it's not approaching it from either side,
Yeah.
and it doesn't like determine a side, what do I put there? 'Cause it does not
Does not exist. Yeah. So the difference between something like A, where the point is missing, that's undefined. But if the limit is not approaching, because like D is 0, E is 3, so that limit does not exist because they're not approaching 0. Yep. Yeah. Yes. For L, L is still does not exist. Now, J and K and L, truthfully, don't exist because they're not approaching a null. And so I'm happy to take either of those answers. But for something like J and for K, I'm going to write negative infinity because those one-sided limits, we want to tell that better story. I want to know what direction it's heading, especially then once we get to section 6 that talks about one-sided limits, right? Simplify if necessary and input a test value to determine if that limit approaches infinity versus negative infinity. So it's kind of that same mindset. If I'm coming from one side, I can say something, right? I can give you an idea of where we're headed, whether it's a number or whether it's positive or negative infinity, I can do that. But definitely for L, does not exist. Yep. And that's why I picked this one. I searched for a while to find this graph. I was like, I wanted to find one that has an asymptote, but they're both heading in that direction so we can have that conversation. Yeah, we did. That's what's up?
Pi check 2.
I got root 2 over pi. Because you've got root 2 over 2 over pi over 2. The 2's cancel. Root 2 stays up top, pi stays at the bottom. Number 8. Yep. Yep, root 2 over pi. 12 is not working out the way I expected it to. Multiply it out. Oh, duh. There we go. I'm not factoring it. I'm actually doing it right now. Yeah, let me finish that one up. If factored, then I should be able to simplify the 2x minus 3's. So divide those away. Ooh, I gotta plug in 3/2. Ooh, that'll be interesting. All right, let's see. 4 times 3/2 squared plus 6 times 3/2 plus 9 over 1/2 minus 1. Okay. So that's 4 times 9/4 plus 18 over 2 plus 9. So 9 plus 9 plus 9 is 27 divided by 1/2, so 54. Like for which one? On top there, that 3x squared? Yeah, that's a good one. So, what is it? 3x squared plus 8x minus 3? Okay. So, we're always trying to figure out, right, what adds to b and what multiplies to a times c. So b is 8 and a times c is negative 9, right? And so that pair is going to be 9 and negative 9. Now, what we can do to avoid factoring by grouping or kind of the longer way is we can factor this as if a was 1, right? X plus 9, x minus 1, knowing that that's not really the truth, but just kind of a step in between. So we set up our diamond problem, or like, two numbers that add to 8 and multiply to -9, however you want to write it. Set it up with just the x's. Then divide your numbers by a. Divide the 9 by 3, divide the -1 by 3. If the number goes in perfectly, then do it. X plus 3. If the number does not go in evenly, that number is your coefficient of x in that factor and that number at the end of it. Yeah. Super, super nice. My favorite. Like, I showed that to the math department at lunch like a week ago, and they were like, their jaws literally dropped. They were like, what? I've been doing it this long way for, nobody knew what I was talking about. It was amazing. It was so cool. It's still up on our department whiteboard in there because they're like, oh my god, this is so cool. This is amazing. Why am I ever factoring by grouping? Why am I ever doing the box? If this way always works. And God, I wish I just understood why. I don't know, why does that work? I haven't really dug enough into it to figure out why that algorithm works the way it does. So, I don't know.
What about number 10 on the bottom?
Aha! Number 10 on the bottom, 9x squared minus 1. That is 3x squared minus 1 squared, the difference of 2 squares. First one goes first, second one goes second, one's a plus. 3x minus 1, 3x. Ooh. Anything else that you need to catch up on, or is that the last one?
Yeah, I might be thinking of
Okay. Everything is, you should get caught up. You have. Definitely want to be all caught up. Cool. Thanks, Sarah. See you later. 15, 16, and thirds. 16, and 3. Mhm. you a couple of things. This is a way to kind of address that. Working for that solid half hour. We didn't get a chance to actually watch this in class. I sent it to you guys at home. We did, but I don't know if you remember watching it. So I want to show it to you again, but I also have another one that I wanted to show you right after this. But I just wanted to remind you of this cool little experiment first. Once Grammarly tells me how to write. Thanks, Grammarly. I should probably download that. Just in case you didn't get a chance to watch it or didn't really dig it yet. Since I got on my trig stuff, let's watch it. 24 hertz on a 24 frames per second camera. Can't see it with the naked eye, but the camera can catch it. That's just too crazy. It's not really a trigonometric wave, it's more of a spiral. It's a three-dimensional kind of experience, and you can kind of see it like it's turning that way. It's kind of doing this. The tube is not moving perfectly in just one single plane. It's kind of shaking around, but we can't even see the tube move, which is pretty cool. That's the part maybe I like the most, is you can't even catch the tube moving. But you see the water. This one's really cool. You can hear it. You can hear how fast the water's coming out. That is not in slow motion. So crazy. But the backwards one is by far my favorite one. But that's just so cool. This one. Come on. So cool. Now the reason I wanted to show you this again is because I have another one. And you'll see it comes up a little bit. Sematics. Okay, the visualization of sound.
Make a different future. Start different and go
This is a little longer. I think it's like a 5-minute music video. It's pretty cool. Like,
the film you're about to see has no characters. If you spare a little of your imagination, it is a film to describe to you the effect of cymatic frequencies of matter.
Tesla coil. Regular Tesla. What does it really sound like? Oh. That's pretty awesome. It's all real. So cool. There you go. All right, that's slow motion. Pretty cool. But yeah, the last thing is a Tesla coil. You can check it out. If you think Tesla cars are cool, you should really figure out what Nikola Tesla did before he got to that point. There you go. Pretty awesome. We still have a couple minutes, so hang out. I'm gonna just kind of keep working on this. I got through 24, so that's like halfway, a little more than halfway. Because I'll still have to do the test itself. And so I'm hoping to have it done by tomorrow so I can put it up so you can check it out. And then, like I said, tomorrow you can just log in, get yourself checked in for attendance, and then log off if you want, or of course stick around and ask questions if you like to. That's awesome. And then I'll see you back here on Thursday.